Okay, so in our last video, of course, we talked about these whole ideas of the trigonometric ratios for 60-degree angles. So if I have a 60-degree angle, I certainly know that my ratios go something like this. If the hypotenuse has a length of 2, the adjacent side would have a length of 1, and the opposite side would have a length of square root of 3. But now a nice thing to remember is that, well, we don't have to necessarily stick with this idea of having a 60-degree angle, right? Because the complement of 60 degrees is 30 degrees, right? So let's take this 30-degree angle. What can we say about it? In this case, if we take it and we flip it on its side, right? What happens? Well, our 30-degree angle now becomes the primary, but what happens to all the sides? Well, we still have a hypotenuse of 2. That hasn't changed. However, the opposite side for our 30-degree angle is 1, and the adjacent side is now square root of 3. And so, lo and behold, if I'm asked to find the sine of the angle 30 degrees, what I'm actually going to find is the ratio of the new opposite and adjacent 1/2. For the cosine of 30 degrees, I get the adjacent of the hypotenuse square root of 3 over 2. And I want you to notice something. This is what we kind of did in the last section. We were talking about 60-degree angles, but look at what's happened. They've switched, right? This is now the cosine of 30 degrees. This is now the sine of 30 degrees. And we know that because all we're really doing is we're taking that 30-degree angle version of this same triangle and just getting the corresponding ratios to those, right? As a matter of fact, if you're curious, the word cosine is actually the complementary sine, the complement sine, right? So the co and cosine comes from complement. We're taking the cosine of the complement of our sine. Isn't that nice? So we get tangent of 30 degrees now to be our opposite over adjacent. That's 1 over the square root of 3 in this particular case, but we rationalize that denominator to make it square root of 3 over 3. And then we keep going. Our cosecant of 30 degrees, the reciprocal of sine, is equal to 2 over 1. The secant of that 30-degree angle, that's 2 over square root of 3. But we rationalize that and make it 2 times the square root of 3 over 3 when we express it. And then, of course, our cotangent of 30 degrees is going to be 1 over the tangent, or in other words, square root of 3 over 1. Now, how about this pi over 6 business? Well, once again, we see that pi over 6 is the complement to pi over 3. And just as before, when we rewrite that in terms of degrees, we would see that multiplying by 180 over pi would give us the same thing as 180 over 6 after we cancel out the value of pi from the numerator and denominator of our respective fractions, and that reduces to 30 degrees. And so pi over 6 radians is equal to 30 degrees. So, rewriting this, if I asked you to find the sine of pi over 6, you should definitely tell me that the sine of pi over 6 is equal to 1/2. Because it's the same thing as taking the sine of 30 degrees. Pi over 6 radians is the same amount of rotation. Cosine of the angle pi over 6, consequently, is going to be square root of 3 over 2. And the tangent of pi over 6 is going to be equal to, let's see, 1 over the square root of 3, or square root of 3 over 3. Well, it is the tangent of 30 degrees, so it's the same thing as we talked about before. And so these would certainly keep on going. Okay, so more to talk about in the next video.